Alrighty, welcome back and welcome to semester 2. We are going to be starting our module 4 notes today. So this module is actually pretty short. It's only 3 sections, and so we're not going to do everything that is in this module in our textbook. So this module is about linear and nonlinear functions. We're just going to be focusing on linear, so lines, okay? So remember, anytime we see this word linear, we're thinking about a line, and a line looks like this on our graph, okay? So that's our main idea for this unit. We're going to be graphing, working with slope and things like that, okay? Before you get rolling with the video, I want you to go ahead and read through these kind of learning targets here and answer whether or not you know how to do these things before our module begins. So the first column would be no, I don't know. Middle column, kind of, no. Far hand column would be yes, I could do this. So go ahead and pause the video, fill this section in based on the learning targets we're going to have today. All right, once you've got that done, we are going to start in on lesson 4.1, which is about graphing linear functions. So again, we're going to be putting lines on a graph. Before we get into that piece, I do have a little warm-up that I'd like you to try and do on your own before you get into the video. This is talking about domain and range. This is from module 3, so it's a little bit of a recap of what we've done so far. Just as a reminder, when we're talking about domain values of a function, those are our x values, range are our y values, and then we're also going to determine whether each relation is a function or not. Okay, so for this piece, yes or no. Remember, functions, the x's do not repeat. Not a function, they will repeat. Okay, so again, we're looking for domain and range in this first set of ordered pairs. Again, domain is all of the x values, so it's all of these first numbers here in this set of data. When we write domain, we are going to make sure we write those in curly brackets, so draw those as best as you can. And then we're just going to list off those numbers, 7, 4, 3, and 2. All of those are unique, so we would all just list them all out. And then range is our y value, so that's our second set of numbers here. Again, we're going to start with curly brackets. So 2, 3, 4, and then there's a second 4. But remember, we're just going to write those once in our domain and range list. Again, when we're looking at whether or not a relation is a function, we're going to be looking at the domain piece here. Domain, none of those values repeated, so yes, this one is a function, okay? I'd like you to go ahead and pause the video and see if you can fill in the rest of this warm-up. Again, make sure all of your domain and ranges start with curly brackets and end with curly brackets. And then on number 3, this first column is x and the second column is y, if you need help reminding that. Okay, so go ahead and finish this warm-up, and then you can move on then to the next piece here. All right, so our goals for this section, and we're just going to do the first learning target today, which is graphing linear functions by making tables. Okay, the next day, our next class period, we'll talk about x and y intercepts. So, with today's lesson, a table of values can be used to graph a linear function. Every ordered pair that makes the equation true represents a point on its graph. So a graph represents all the solutions of an equation. So whatever x's and y's work together, those are the points that are on our line. Linear functions can be represented by equations in 2 variables, okay? The 2 variables that we're going to be working with are x and y, okay? So all of our equations will have an x and a y with it. There are some special equations that we'll talk about in our next lesson that don't always have an x and a y, but they'll have one of them, okay? So this next question here is talking about what values are we going to use in our table. So with our table, we're going to be making an XY table with some stuff in between. And my question is, what values of x might be easiest to use when graphing a linear equation when the x coefficient is a whole number? Now, this word coefficient, that means the number in front of x, okay? So when my number in front of x in my equation is a whole number, what are some good numbers we would choose, okay? We are going to actually pick specific numbers, but in general, the numbers that you would want to choose would be numbers closest, sorry, that wasn't very good, closest to 0, 0, okay? So we're going to actually pick numbers that are close to the point 0, 0. This is also called the origin. We want to pick these numbers because they're going to stay on our graph and not go off of our graph, okay? All right, so now we're going to actually jump into some examples here. So if we go on over to the next page. So this is what our problems are going to look like. So it is going to say make a table, and then we're going to actually graph it. Okay, so all of these two slides go together, 9 and 10. So step 1, it says choose the values -1, -2, -1, 0, 1, and 2 for x. Okay, so we're always going to pick those numbers. So those are going to go in this first column here for x. And then we're going to substitute each x value into the equation to find the corresponding y value. Okay, so that's part 1. Then we're going to write our ordered pairs. Okay, so here's our equation that we're going to be using. And I'm going to rewrite it slightly different so that it's y equals in the middle part of our table right here. Okay, so this is going to be where our equation goes every time, and I'm just flipping around the order. So saying y equals -2x minus 3. Now what we're going to do is you're going to take just this part only, and we're going to use that down this middle column. But what we're going to do is we're going to replace this x with the numbers that are in the first column here. Okay, so what this is going to look like is the -2 is going to stay the same from here, okay? But now my x in this first row is also a -2, so that replaces. And then the -3 is going to come down like so, okay? Now, I like to fill this whole column in first and then go back and do the calculations. So, again, the blue -2 in the front stays because that's what's in our equation. The x spot is now going to become a -1. And then that -3 on the end is going to stay as a -3 because that's our equation. Then we'll have -2 again. This time our x is a 0, -3, -2. This time our x is a 1, -3, and then -2, x is a 2, -3. So once you get your whole table filled in, you're then going to do each calculation to figure out what your y value will be. So whatever these are equal to is going to be what y is equal to. Okay? So if I multiply -2 times -2, that's 4. 4 minus 3 is 1. So this first y is going to be a 1. You can do this middle column using a calculator as well. -2 times -1 is 2. 2 minus 1, or minus 3 is -1. If I calculate the next one, it's going to get me -3. The next one's going to get me -5. And then -7. All right, so now what we're going to do is we're going to put our x number and our y number together to create an ordered pair. So ordered pairs are in this last column, so -2, 1. Those need to be in parentheses, comma in between the values. -1, comma -1. Again, x and y. This one, x is 0, y was -3. This one, x is 1, y is -5. And then we've got 2, comma -7. Okay, so that's how we make our table. Now we're going to use our table in this next piece. So step 3, again, these go together. Step 3 is we're going to graph the ordered pairs in the table and connect them with a line. Biggest thing we have to remember is when we graph a point, it's x comma y. X's move right when they're positive, and we move left when we're negative. So if our first number is a positive number, we're going to go to the right, which is this direction. If we move to the left, we're going negative, which is that direction. Y's are up when they're positive, and then they're down when they're negative. Okay, so we move an x direction first, then a y. So for example, this first point, -2, comma 1, the -2 tells me I need to go left 2, and the 1 tells me I'm going to go up 1. So if I look at my graph here, -2, comma 1 will be left 2, up 1, and then we're going to put a point. Okay, so that is the first point, -2, comma 1. Our next point is -1, -1. So left 1, down 1 is going to be right here. 0, -3. So 0 means I'm not going left or right. -3, I'm just going to go down 3 on my y-axis there. Okay. 1, -5. So my x is turning positive now, so I'm going to go right 1. And then -5 will go down 5, put a point. And then 2, -7, that's going to put me right here. Now, once you have all of your points graphed, you are going to now connect all of them using a ruler. I have rulers, and I will make sure you guys have one today, but I want to make sure that you get a nice straight line when you connect those points there. So it seems like a lot of work, but it should go pretty quick once you get a good start on it. All right, we're going to look at one more example, and then we'll be done for today, and then you'll have some practice. All right, so looking at slide 11 here, again, we're going to graph this equation, and then we're going to make our table, then graph, okay? So here's our equation. That's going to go in this middle part here, y equals 2x plus 5. We're always going to pick the same x values, so -2, -1, 0, 1, 2. We're going to take our x out and make it the numbers that are in that first column. Everything else is going to stay the same. So this 2 stays a 2. But where x is going to become a -2 because that's the first change we'll make, and then plus 5. Now what's blue is what's going to be filled in differently, okay? So I'm going to have the 2 in front again, but this time in my parentheses it'll be -1 plus 5. Keep the 2 out front. Now it's going to be a 0 plus 5, 2, parentheses 1 plus 5, and then 2 parentheses 2 plus 5. All right, and then now we're going to calculate that middle column. You can use a calculator to do this. 2 times -2 is -4, plus 5 is 1. The next one will get me 3. Then 5. If you want to do these calculations, you can. Then 7, and then 9. Okay, so those are our y values. Now we're going to combine our x and y column to make an ordered pair. So negative 2, comma 1, negative 1, comma 3, 0, comma 5, 1, comma 7, and 2, comma 9. Now we're going to plot these numbers, okay? So again, x first, then y. My x for this first one's negative 2, so that means I'm going to go negative in the x direction, 2, so left 2, and up 1. So my first point should go here. If it helps, something you could also do on your graph, these are my x's that are positive. These are my x's that are negative. These are my y's that are negative, and these are my y's that are positive. So if you want to write that on your graph, you're more than welcome to kind of help you out there. All right, negative 1, 3, so negative x, 1, and then up 3. So we'll be right about here. 0, 5, so not moving right or left, and just going positive 5 for the y. Right 1, up 7. Right 2, positive 2, up 9. And that's where our line should be. We'll go ahead and connect our points. Another thing, make sure you have arrows on the ends of your points in your line, and then you should be good to go. All right, that's where we're going to stop for today, and you do have a practice that goes with this.